Okay, good evening. So let's start. So today we'll talk about. Can you see
Yeah.
my screen?
Yes, Om.
Yeah. So today
I
we'll
can see you.
yeah
I can
today
see the screen.
yeah. So today we'll see the see regarding the schedulers and the node labeling. So specifically we'll talk about capacity scheduler, how to configure capacity scheduler, and also we'll understand what is the importance of the capacity scheduler over the other schedulers. So the three prominent schedulers or the three most popular scheduler, which is used in Hadoop, they are FIFO scheduler. Then you have a capacity scheduler, and then you have fair scheduler. The scheduler name itself suggests that you wanted to schedule how best how basically you wanted to schedule your jobs, schedule your jobs, and it's basically a scheduler. A best scheduler would be the one who actually gives equal amount of resources to all of the jobs which are getting submitted. Now when we talk about resources, what are the resources we are talking about? The resources is like we have two kinds of, we have a CPU and the memory. So how efficiently we utilize the CPU and the memory uh, now over the among the various jobs that can that are that will be submitted, right? So now so basically we'll talk about in with respect to yarn framework is basic containers. So when the containers are getting launched, so what should be the minimum CPU, what should be the minimum memory that will be allocated to each of the containers that are submitted. Now you have this FIFO scheduler. It stands for
Hello.
first in and first out scheduler. Now FIFO is your the very basic scheduler, but the problem with the FIFO scheduler is once the job is submitted, you won't be able to submit the other jobs. You won't be able to submit the other job until the first job is finished. Until the first is finished. So FIFO scheduler was generally not used, is generally not preferred to use. Now the problem again, let me again emphasize what is that FIFO scheduler, which is the default scheduler in Apache Hadoop. In that scenario, when you use Apache Hadoop, you have to, I mean to say, yeah, you the default scheduler that comes with the Apache Hadoop is your FIFO, which means that once the job is submitted, you won't be able to submit other jobs until the first is finished. Then what is the problem here actually? If there is a long running job and if you want to fire some ad hoc queries like Hive queries or Pig queries or some kind of a minor MapReduce jobs, then you have to wait till the job is finished. Ad hoc query, then you have to wait till the job is finished. That is a problem with your FIFO scheduler, but that's why it is generally not preferred to use in production and all. So FIFO scheduler is a default scheduler for Apache Hadoop. Capacity scheduler is a default scheduler for your HDP, and the fair scheduler is for the Cloudera distributed of Hadoop, distributed Cloudera distribution of Hadoop. Yeah, and this is HDP. Capacity scheduler is your default scheduler for HDP. So these kinds of schedulers are generally developed so that you have the flexibility to divide the resources among the various jobs, right? And you should be able to do all these things. If there's a long running job, then you should make sure that it does not consume all the resources. It should leave some resources for the ad hoc queries as well. There should not be any scenario wherein only single user is running, a single user submitting your application, is submitting the application. So what I'm trying to emphasize here is there are a lot of scenarios wherein you can consume the entire resources, but your scheduler should be in such a way that should be safeguarded against any kind of application or a user or any kind of a job. Okay, so you should have at any given point of time your resources should be safeguarded. So that's why you have various schedulers that came into place, and a specific scheduler which we talk about is the capacity scheduler. So capacity scheduler. So what is okay? This again, this capacity scheduler. The main motivation of a capacity scheduler is a multi. It is used for your multi tenancy, for a multi tenant cluster. Okay. So what does it means multi tenant? So multi tenant. This is your word, fancy word for sharing the resources. Okay, and the resources are for sharing resources among various users. That's users are nothing but tenant. Okay, I hope you understand the meaning of owner and tenant, right? You are the owner and tenant. Let me explain you. That's the same thing. Now, now let me take an example here of a building. This is your first floor, second floor. I'm taking three floors only. Three floors, two families. So first family, second family, third family, fourth family, fifth family, sixth family. I can say it's a six tenant. Now, shared resources. Now, tell me what are the two shared resources? You have water.
Water, electricity.
Right. You have the water, which is going to be shared, and then you have two things, which is electricity. Now, these are two shared resources. It should not never happen that this fifth floor, I'm just taking an example, this fifth family should not consume all the water. It should be safeguarded in such a way that all these resources, all these tenants should get a fair amount or a guaranteed capacity of the water and electricity. Each of these families, each of the tenant should get guaranteed capacity. Then only you will stay in that apartment, right? Guaranteed capacity of water and electricity. Okay. Also, let's say there are only, okay, if you see, let's say we take about the 100 liters of water daily consumption. So this 100 liters of water should be consumed by all these five. We should have all this. They should have the guaranteed capacity of 100 liter. Means if all the five families are here, each one of these families should get a guaranteed capacity out of this 100 liter. If let's say uh, if these three families has gone out for vacation, then it does not, so these three can get extra waters, right? These three can get consumed, these three families can consume extra water, which basically means that we can get elasticity, elasticity if the resources are ideal. It's the same concept which we see in the real time. Okay, so keep this building and the water electricity in mind, and let us see the concepts. It's one of the pluggable scheduler for Hadoop. When you say pluggable, it basically means that you have the flexibility to change the schedulers. You can plug and play. If you're not happy with capacity, you can use pair. If you're not happy with fair, you can use some other scheduler. You can use FIFO, or you can use some other scheduler. Now, capacity scheduler, the motivation is we wanted that it should allow a scheduler should allow multiple tenants to securely, yes, share a large cluster such that their applications are allocated resources in timely manner under constraints of allocated capacity. If you want, uh, if you want to again make sure the same diagram, it should be secure, right? You are living in an apartment, should not never happen that the neighborhood apartment is taking your water and electricity. It should be secure. That means in a cluster, the resources should be confined to that particular cluster. It should not be accessible. It should not ever happen that the other cluster is trying to access your resources. That's first thing. Share a large cluster such that applications allocated resources in timely manner under constraints of allocated capacities. So you have 100 liter of a water, and then you can only consume 500 units of 1500 units of electricity a day. So this is under constrained allocated capacities. Your applications are allocated resources, of course, because everyone takes bath in the morning. So all of them should get a guaranteed capacity of water, electricity, whatever it is. We should be sharing a cluster in a cost-effective manner for running large Hadoop installation. Okay, now when you talk about here in organization, they actually this bit is actually something like this. Whenever you are building a Hadoop cluster, actually you are, for example, you are a QA. There are three, four departments: QA, Dev, and Prod for a given product. Let's say there are a lot of company, I mean to say departments like QA department, Dev department, your production department for a given product. Now all these departments are separate department, but they wanted to actually run their jobs and find out some information. Let's say sales is also there. They wanted to have the data shared, and also they wanted that they should I mean to say you will be creating a cluster keeping in mind that your data will be accessible across many organizations. So in that case, what you will do, you will all these departments comes together and they will pool the money and say that okay, QA guy says that I will give 4 machines. Dev, I will give 3 machines. Prod, I will give 15 machines. Sales, I will say 10 machines. So total, it's a 30 node Hadoop cluster you are trying to form, let's say. Okay, a 28 or 30 node Hadoop cluster. But here the organization, that means these various departments, they are very concerned about sharing a cluster, because they might think that since they are sharing a cluster among various resources, they will have a doubt that what will happen to my SLAs. Because they have given 4 machines or they are given 15 machines, and they are saying that we will share our resources among these various organizations. So they are worried about their SLAs. So we need to actually think that how can we share a cluster in a cost effective manner. Now that's where a capacity scheduler says that you will see that in a short while that there are various configurations wherein this capacity scheduler will allow to share a large cluster while giving each organization a capacity. A guaranteed capacity will be given to each one of them. A guaranteed capacity will be given to each of the organization, or you can say organization, here you can say that tenant. So here again, see, available resources in the cluster are shared among multiple organizations who collectively fund the cluster. That's what I was saying. They will collectively fund the cluster based on their computing needs. Production, they wanted to have 15 because yes, because production you need hi-fi machines or you need more computation power. So based on the computing needs, they have funded the cluster. And also it is very important to understand organization can access any excess capacity not being used by others, which provides the elasticity in a cost effective manner. So QA guys, for example, none of the jobs are running for prod, sales, and QA, let's say. So dev guys will get all the 30 or 28 machines to run their job, which means that actually they have got the elasticity. That means they have increased the computation power in a very cost effective manner, right? So that's what capacity gives us. And remember that when you are sharing a cluster, we should support a strong multi-tenancy. It's basically the one which we have understood. That of course, when you are sharing a resources among the various when you are sharing a resources, shared resources, there should be a strong support for that. Actually, calls for a strong support for multi-tenancy. And
So,
yeah,
sorry to interrupt you in between. I have one doubt regarding this multi-wood tenancy. Does multi-tenancy means multiple map reduce kind of job or different kind of jobs which can run
what?
simultaneously?
Okay,
Is it one kind of job or multiple?
what is the tenant means?
Tenants means different people, like for as you
User
explained
one,
in the building
user 1,
context.
user 2, user 3, user 4. User 1 is Som, user 2 is Sajid, user 3 is Nitin. Okay, user 4 is Vipin. You can submit the map to his job. You can submit the map. He can submit the map to his job. He can
Yeah.
submit the map to his job. This user Som and Sajid belongs to QA. Nitin and Vipin belongs to Dev. Now tell me, does it answer your question that it can be multiple jobs from the same user? It can be
Oh,
different jobs from the different users.
yes. Yes, yes.
Okay.
Thanks so much. It was a very good explanation. Thanks so much.
Yeah, and that should, and each one of this should get the shared. They should be allocated a guaranteed capacity. Yeah. So each organizer must be guaranteed capacity and safeguards, and to ensure that the shared cluster is unaffected to a single long rogue application or user. This is again very important that the resources should be safeguarded. There are two kinds of things what can happen, wherein your resource outage can happen. So resources should be safeguarded against a single rogue application or a user. A single rogue application means that the single long rogue application. Rogue means you actually, it's the English term which means that he is very rogue person or he is very rowdy kind of a person or he wants to capture each and everything, right? So single long rogue application, it means that the application should not consume all the resources. So which means that we should put a limit on how much amount of a resource, how much amount of a resource an application can consume. Second, the user. Now it should not happen that only one user should is submitting the jobs continuously. So we should put a limit. So there should be a limit on number of applications that can be submitted by an user. So there should be a safeguarded. So our resources should be safeguarded against these kinds of worst case scenario wherein an application consuming the disproportionate amount of resources and a user who is continuously submitting their jobs and jobs or applications. So we should put a restriction on what kind of how many applications or how many jobs he can submit at one time. So these kinds of restrictions are necessary. So capacity scheduler is designed to provide stringent set of limits. He provides a stringent or a strict set of limits to ensure that a single application or a user cannot consume a disproportionate amount of resources. We'll talk about Q in a short while. So it provides so capacity scheduler will you see that you can provide a limit on applications from a single user, and everything is a design on a queue. So you have basically the primary abstraction is queue, which will be set up by administrator. Now in capacity scheduler, you actually define a queue, and it's a normal queue you can think of. That's jobs are submitted from here, and then it gets taken up from here and then submitted. And the best part of here it is it supports a hierarchical queues, and that is important to ensure the resources are shared among the sub queues of an organization. Okay, so basically what I mean to say right now, if you think about queue is LIFO, right? Last in, first out? No. What is queue? First in, first out.
First in, first out.
Right.
Yeah, FIFO.
Yeah. So stack is LIFO, no? So queue
Yeah,
is
Yeah.
that,
FIFO, first in, first out. Okay. So you might be thinking there should be, if there is only one queue, then it's the same problem of a FIFO, first in, first out, because the jobs
Yes.
will be taken up from here. But the best part here is you will see there is a support of an hierarchical queues in um, in capacity scheduler. So actually, you, for example, I have three departments. I have QA department, wherein there are two guys taken, for example, Vipin and Nitin. Dev, I have X, Y, Z. Sales, I have Som, Sajid. There are three departments. Now, what we do actually here, we actually can create a. Hmm, let me just make them an under engineering. QA and dev comes under engineering. This in the sales you can have advertisement and marketing. There are two kinds of people, right? In the sales you can have advertisement. Under advertisement you have a SOM. Under marketing Sajid is working. Okay, and then you can have some other some other department. Let's say X department. Under that I have two kinds of departments, A and B something. Now what we can define a root queue. That's a basic queue. Then under that you define various organization. That's your engineering, sales, and some other. Under engineering you can again create a departments like QA, dev, advertisement, marketing, and something like this. And when you submit a job, actually it's submitted at the leaf level. So you will submit a job, and the jobs you want to say that jobs I want to submit a dev. You will set in a very short while that how we will allocate the resources in the percentage manner. So I want to say dev. So again, these are the leaf level queues. So actually, if you see, there are multiple queues at each of the leaf level, and the jobs will be submitted from here. So when the jobs are getting submitted from each of these queue, it will be in a FIFO fashion. I'll explain later when it comes again. So capacity scheduler provides hierarchical features, hierarchical queues. The one I have just explained now. It will ensure the guaranteed capacity in each of the for each of the tenants. It will ensure guaranteed capacity. So capacity is guaranteed. It will ensure for each of the resources for each of tenants. Secured. So you will see that I mean to say Here, secure, it's each and everything is it's secure it's secure. When you're submitting a job, you will be seeing that you will be actually map the user to the various queues. So that way, you are secure that you will not the different users cannot submit a job to different queues. So each of the user will be mapped to a queue. Elasticity, the one I have just explained, that if any excess resources, if any excess capacity which is not being used, you can actually use it. That provides elasticity in a cost-effective manner. Multi-tenancy, operability, resource-based scheduling, and the queue-based mapping. So resource, based on the resources, you can actually schedule your jobs. So that's why it is it is telling you that for each of the applications that gets submitted, a guaranteed capacity is guaranteed, and a queue mapping, and you can actually map your user to the various queues, and you will see that very soon that how it will be done. So if you want to use um, capacity scheduler, you actually set up this property, a yarn.resource manager or scheduler class. Which scheduler you want to use it, you use actually capacity scheduler. So that's how you're going to define it. By default, it's already set in Ambari. If you want to use something else, fair scheduler, then you have to give the appropriate class name. And this is, for example, we want to configure, and this is where we are going to take up this example. I will say that we have a three organization: support organization, engineering organization, marketing organization. Under support, we have a training and services, engineering, development and QA, marketing, sales and advertisement. So these are my parent queues. Under parent, I have a leaf queue. Under development, if you have something else, then you can do that. Big data team, and then big data QA, something like this. You can again further bifurcate. Can then further you can split. It's just a logical queues. And let's say if you want to support the same thing like we are seeing right now, so configuration wise this will do. You don't have to do when in Ambari you don't have to do any of these things, but here let's understand this configuration XML files, that what goes behind the scenes. So you wanted to specify three schedulers. If you see that, go back and you will see, you keep this diagram in mind. We are going to do the configuration uh, the way it is done. Under root, I want support, engineering, marketing. Under support, we have a training and services. Under engineering, we have a development and QA. Marketing. Under marketing, we have sales and advertising. So you first define what all queues you want under root. Root is the default queue. So you don't have, so it will start always the root queue. Root is the default. Yarn.scheduler.capacity.root.queues. Under root, I want support, engineering, marketing. Now you see yarn.scheduler capacity support.queues. Under support, training and services. Yarn.scheduler capacity engineering. Under engineering, I want development and QA. Under marketing, I need sales and advertisement. Okay. Now this is just you can see it's a very straightforward, simple how the configuration will be done. Now top level queue is a root queue that does not belong to any organization. It actually represents the cluster itself. It does not belong to any organization. Okay. Your parent queues, like the one which we have seen, it enables the management of resources across organization, sub-organization. So it contains more parent queues or leaf queues. So you have seen under engineering, so you defined a parent queue. Under parent queue, you have defined sub queues like dev and QA. And under parent queue, you cannot submit any applications. You have to submit only on the leaf level queues. You can submit the job only on the leaf level queues. So if you see how scheduling is done, actually your root key understands how the cluster capacity needs to be distributed. Then every parent queue applies its capacity constraints. We have to define the capacity constraints for each of the parent queue, and every parent queue applies its capacity constraint to all of its child queues. And the leaf queue will hold the list of active applications and schedule resources in a FIFO manner. That's what I've explained you. In the leaf queue, in the leaf level queue, when the jobs are getting submitted, so it will be taken as a FIFO. And actually what we do here, we provide an access control on a parent queue. So application submission happens only on the leaf level queue, but whatever restriction you provide on the parent queue, that will be applied to all of its descendant queue. For it, you will now let's say right now you might not get the correct idea here. So let me just go back to what actually how this ACLs and everything can be, or how these capacities actually are assigned. Okay, it's not given here, so let me take this example. So your capacity is actually defined in the terms of percentage. So by default is 100 percentage. Out of 100 percentage, I want to decide that I want to give 30% to support, 40% to engineering, and the remaining 30% to marketing, which is equal to total 100%. At any level, it should be 100%. 30, 40, 30. Now out of 30%, so since you have defined it's a 30%, then 30, out of 30%, for example, I want to give 60% for training, 40% for services, 80% for development, 20% for QA, 10% for sales, 90% for this. Okay. Now, if I, let's say if I want to do this, if I have to take an example, I wanted to give 100 as my 100 rupees, 100. Out of this rupees 100, 30 rupees will be given to support, 40 rupees will be given to engineering, 30 rupees is given to my parent, I mean to say marketing. Out of this 30 rupees, what is 60% of 30 rupees? 18, eh?
Yeah, 18 is.
18. 18 rupees will given to training, and the rupees 12 will be given to services. 40. 32 rupees, what is 40, 80%? 32 rupees. 32 rupees will be in development, and 8 rupees will be given to QA. Marketing, 30% or 30 10% would be 3 rupees will be given to sales, and rupees 27 will be given to advertisements. So this is how the resources are actually divided among the various queues. So it is not with rupees, it will be with respect to your resources like memory or CPU and everything. So this is how. So constraints. So you see that constraints, whatever you the constraints are applicable to your support, it will be descendant, or it will be applicable. It will be descendant to its child queues. So whatever constraints you are putting on parent queue, it got it got applicable to its descendant queues. Yeah, tell me.
Yeah, so I have a question here regarding this. You explained like capacity sharing of capacity in terms of percentage. So can this be changed dynamically, or is it decided only during the startup of the cluster? I
No,
mean to
it cannot.
say,
It cannot be. It
suppose
cannot be done. It cannot be done dynamically.
Okay, so once view has set, unless you restart, then when the policy it will be same during that run, right?
Yeah. So yes, ACLs are configured by guaranteeing queue access to a list of users and groups. So access control lists are configured to say that um, which all users and groups are applicable to submit the job. So here you are providing a root. Okay, so you are not providing any value here, which means that no one can submit the job at the root queue, which you don't want it, right? It should, because the jobs are submitted only at the leaf level. So no one can submit the job on the root queues. Now here you are saying yarn.scheduler capacity under root.support ACL submit application. You are saying that now which all users you can support. So it says that user 2 and EC2 user and root can submit the job, and also the group EC2 user slash root are the groups. So this is the user list, and this is your group list. Both are separated by space. So you can define each of these things. There are a lot of other things which you can also define. Let me just quickly take you through that. Who all can administrate the queues? So here it is controlling the access to the queues. So a separate ACL can be used to control the administration of the queues at various levels. So queue administrator can submit the applications to a queue, kill applications in the queue, and obtain information about any application in the queue. So it's basically setting up that who can control the queues. And here again, yarn.scheduler capacity root.acl administrator queue. Here the value of a space, that means no one can able to do anything at the root. And here under root support, you are saying that EC2 user root space EC2 user root. So this is your user list space user group list. You can provide the list of users, list of the groups who all can do whatever I'm into for this, in this case controlling the properties. Queue mapping based on user or group. Now you want to map the user based on the you want to map the user or a group of users to a particular queue. So for example, the idea could be that every time you submit a job, he does not have to specify that which queue he wants to submit a job to. So if you provide a mapping, then it will automatically, by default, it will go into that particular queue. The job will be submitted to that particular queue. Now, administrator can define a default mapping policy to specify that applications submitted by user are automatically submitted to those queues which has been defined. So the motivation here is why we want to do that is users are not required to specify the queue name when submitting the applications. So you will see that when we submit a job right now, every job we have seen in the last classes that we have submit a job, right? We did submit a job and then it has gone default into the root queue. Now once we provide queues and everything, then we have to actually give the queue name on which we want to submit the job. So in some cases I don't want to give the queue name, then I have to provide the mapping. So queue mapping is defined using a comma separated list of mapping assignments. So here priority is considered from left to right. So a yarn scheduler capacity queue mappings. So here it says U stands for user, Maria engineering queue, G web admins weblog. So the user, the Maria who is a user that can submit directly to the engineering queue. Web admins who is belongs to who is a group, which the group is can do in a weblog queue, something like that. It's just an example. Sometimes the users and the groups are of the same name. For example, in our case, EC2 user is a user, also EC2 user is a group. And to specify that all applications are submitted to the queue with the same name as group. If the users and the same name are group, then you can use this mapping. Not of that important, but yes, okay. Enabling override default queue. So user can override default queue mappings and submit applications that are specified for queues other than those defined in default queue mapping. So if you want that, if you want that a particular user whose mapping is you have done to some queue, but he should be able to provide his own queue, then he can override by this property. You can give that and you can override this property to true. You can set this value of this property true. And the cluster capacity is to be defined with respect as in percentage. And please understand, I have given you that particular diagram just a couple of minutes back, that how it does assigns the capacity. Some of the capacities at any level should be 100%. So here your capacity, root engineering capacity, you're giving 60%. Under root marketing, you are giving 30%. Root support capacity 10%. And furthermore, if you would like divide the capacity of engineering in the ratio 1:4, so it will be 20 and 80%. It's up to you. Whatever the however you want to divide the capacities among the subqueues. Now, I was explaining you in the beginning that setting the user limit, that how many applications a particular user can submit. So the minimum user limit percent property can be used to set the minimum percentage of the resources allocated to each leaf queue user. Okay, to enable equal sharing of the services leaf queue capacity among 5 users, you would set the minimum user limit percentage 20%. Now, what it is means actually, okay, so if you have given as a 20%, okay, and uh, for a given queue, let's say a given queue as a 30, let's say the given queue is a 30, somewhere it is a 30%, okay, 30 rupees 30. Now, if, and what does it means that a user limit is 20. Okay, so when a single user is submitting a job, he will get the entire 30 rupees. When a single user is submitting a job, he will get the entire 30 rupees. As soon as the second user gets the job, he will get 15 rupees. 15. Third user submits the job, it will get whatever, divided by 3. 4 users submit the job, divided by 4. What's happening here? They are trying to share equally among them. But as soon as it gets to 20, which means that that's the minimum user limit. That means I should get actually 10 rupees. Beyond that, if any other user submit the job, to he has to wait for the queue capacity to free up. So you can actually provide this. So in the first scenario, you were getting the entire capacity, but then as and when the more users submit a job, the capacity is getting decreased, but you will get the guaranteed capacity. And for example, 20, so all the 5 users are sharing the resources. 20 into 500% is filled. So the sixth user who will submit the job, he has to wait. Okay. Then here, setting the user limit. So capacity scheduler leaf queues can also use the user limit factor property to control the user resource allocation. And what does it says? It denotes a fraction of the queue capacity that any single user can consume up to maximum value, regardless of whether or not there are idle resources in the cluster. So uh, it says that any whatever it's for a given user. If you want to consume all the resources, I mean, you can define the maximum value that a user can consume, whether regardless of whether or not there are idle resources. If there are idle resources are there or not, it will consume the entire resources. But generally that is not preferred. So what do you do actually? So I'm not sure about this property. I forgot the meaning of this property. We can check it out. And then you have to start the queue by setting this property. But remember that these things you will not do any of these things. Okay. Because Ambari, you will use the UI to do this. Okay, so let me start up my cluster first. We are reaching.
So it's very good theoretically.
I cannot hear you properly.
I was saying it's very good theoretical.
Yeah, it's a theoretical topic. What to do? So you have to understand the configurations. It's theoretical, so you cannot help it, right? Can you?
No, but I mean, my point was still, you made it very interesting. Usually the topics are more theoretical, are very difficult to make people understand. So I was saying in that context.
No, I didn't get you. I mean to say your voice is not actually. So we'll be doing the hands-on. So you have to understand that what is the motivation of capacity scheduler, and then what all configuration is just behind the scenes. So that's what you have to understand that. But rest of the things you don't have to worry about that because you are using the UI to actually do the capacity schedule. So we'll take an example and then we'll submit the job. So that's part we anyways it's pending. So we are it's a theoretical topic in the sense I don't know why you are saying theoretical topic because we have not started the hands-on because before every theoretical because after every theoretical topic I think I have shown you the necessary hands-on so that you understand that. Okay. So you can also place a static configurable limit on the total number of applications. So you can say that on my cluster, the maximum application, let's say you want to define that at any given point of time, my yarn framework should actually run only 10,000 applications. So you can do that. Yeah. And then once you define, so you can see these properties, but these are of not much importance. And once you do that you actually refresh your queues and then you will see that your queues will be created and then we'll see that how to submit the map-reduce job. That's one aspect to it. Okay, that's the one aspect of capacity scheduler. But don't you think it would be a really good feature if you know that if you know that a developer, the developer has given three hi-fi machines out of 30 node cluster. The developer, you are a developer and you know that XYZ machines are really very fast, and whenever I want to submit the job, I want to submit onto this machine. My job should always go into these machines. You really want to do that, right? Some point of time, because out of 30 nodes, you know that those three machines are really good and the hi-fi machines. So whenever I want to submit my job, my job should be submitted to those three nodes. So you actually label the nodes. And node labeling is a concept wherein once you label the node and once you submit the job and you wanted to use those labels on those nodes, the jobs will be automatically be submitted onto those nodes. Okay, we'll talk about the node labeling. It's a very again a very big topic, but we'll talk about node labeling little while. So let us first bring up our cluster and configure our capacity scheduler. Let's start, and then we will open up our hands-on document, and then so this is what we want to define here. Support 10%, engineering 60%, marketing 30%. And then each of the queues, leaf level queues, the training will be 20, services 80, development 20, 80, for the marketing sales 70%, advertisement 30%. Okay. And and all those things which we have done, so we will see that it will be there as a part of the attributes like this: maximum applications, maximum application manager, node locality delay calculator, everything will be there. Okay, and it's like your, I would say, just a UI driven scheduling, UI driven mapping. So everything will be UI driven. Once we have defined our queues, you will see that our application, our queues, where does it, how does our scheduler will change, and then we'll see how to submit a map reduce job on a particular queue. Vipin, you were saying something, I could not follow you. Your voice is breaking, and I'm not able to hear you properly. Still now, your voice is not clear. You can put in a chat
Getting
box.
some issues. Yeah,
Okay. Okay, got it. There no couple of now all the topics are more theoretical. If you see, Kerberos is also there. Now the next few topics are again Kerberos, Knox, Ranger, LDAP, uh, rack awareness, alerts. I think the more we are actually completing, we are nearing to our now our the core admin concepts. No, we don't have to know the configuration parameters at all, because that's only for the information, for our understanding purpose, that what all configurations has to go with respect to Apache Hadoop. But when you see in the Yans, in the Ambari, you don't have to worry about any of these configurations. Okay, you want to say something? No, not at all. Okay. Now, now once this cluster is up and running, you go to click on this. Um, yeah. So you click on this button, and that will bring up your Yarn Queue Manager. So once you click on the Yarn Queue Manager, and before that, before I go into Yarn Queue Manager, let me click on the Yarn, and let me go to the quick links first, and let me show you the scheduler. So the scheduler is right present here on your left hand side. You click on this scheduler, and as I've explained you, the default has only one, that's your root capacity. That's your default capacity, root capacity. You open that, you actually click on this. It has the default parameters, like what is the queue state, what is the configured capacity, everything, absolute use capacity, absolute configured max capacity, use resources, a lot of things are there. Accessible node labels. So a star means none of the node labels are present, and it can access all the nodes. Okay, now let us go back and let us, now you see this here that you have only one root. Now that the now we'll follow our hands-on document and we'll bring up, you will see that we'll have a different queues. So under root queue we have a default queue that's defined it here. So let us see let us go to our yarn queue manager and see our queue. So if you see that, this is how you're going to define your queue. That's exactly, if you see under root you have one queue, default queue. Yeah, now what I want here is to provide three queues which I have defined it here in my hands-on document. I wanted support 10%, engineering 60%, marketing 30%. I need to define three queues under root. Okay, so I'll make it as a 0 because I don't want it. The level capacity is 100, so I can drag it here 0. So once you say drag it to 0, it says that it's wrong, because at 18 level you cannot delete this, by the way. Can I delete it? For example, I can delete it. Okay, I have deleted that, right? Okay, now root has 100%, so I want to say, I want to no, under root I want to define three kinds of queues: support, engineering, and marketing. So I by clicking on the root queue, I click on the add queue and I give the name as support. By default, support will take 100%, but we'll adjust it later. Under root, I want engineering as well. So I click on the root itself and I say add, on the top I say add queue, and then I give engineering. Okay, and then under root I have a marketing. Again, I click on the root, add the queue, and then say marketing. Okay, now support I want 10%. Fine, support I want 10%. I can always give 10% here. Okay, engineering 60%. Okay, I click on engineering, I give 60%, and then marketing 30%. Marketing 30%. Now if you see that, that has become, it was red, now it is green. You can always change the maximum capacity 30%. You can change it to maximum capacity if it changes to 20, 100, whatever you want to give it. It should be actually minimum, whatever, a minimum should be 1. Sorry, yes, minimum should be 1. You can give whatever you want it. Yeah, and whatever the resource, whatever I have actually, if you have followed the topics which have the configuration, see, can administrator the queues, its state is running, can submit the application, anyone can submit the application, who are the effective user limit factor, minimum user limit, maximum applications, everything, it is defined as a you would say as a properties. Now, under engineering, I want to define development and QA. So let's go with support. Under support, I want to have a training and services. Under support, so I'll click on the support and then I'll click on add queues. Training, training. Click on. Then under support only, I need services. So I need to click on support and then add queue and give services. Correct. Now training has to be given 20%, services 80%. Training 20%, services 80%. Okay, you can also change the maximum capacity. Maximum capacity need not be the same, it could be 12%, 10%, whatever it is. Okay, but it says that maximum capacity should be equal or greater than the capacity, so give whatever. You cannot give the least. It says that maximum capacity should be must be equal to greater than the actual capacity, so I can give some greater value. Okay, 85%, whatever value. Now after that, I'll click on engineer. Okay, let's go to engineering. Under engineering, development and QA. Development 20%, QA 80%. So engineering, select the engineering, give that add queue development. Again, Click select the engineering, add QA, and Q development 20% and QA 80%. Marketing again, let's go to marketing. Under marketing we have a sales and advertisement, so click on marketing, add Q, sales, click on marketing, add Q, advertisement. Now advertisement 30% and sales 70%. Okay, that's it, and that's it. You have to do it. You don't have to do anything else. You have defined your queues, you have defined your capacities as well, and you say actions. You click on the actions and say save and restart resource manager. You say restart. What did we change? We have defined the queues. Let us go to dashboard. Click on yarn, quick links. Resource manager connection failed. Okay, let it come up. The active one is not working, so I have gone to standby. But you can see that here. Uh, Q, now the way we have defined engineering marketing support, then engineering has a engineering development, engineering QA, marketing advertisement, sales, support, services and training. And then you click on any of this, you will get it, right? And if you remember when we have submit the job, so it will always have the queue name. You'll see that it has a queue name. So this time when we submit the job, you'll see that you will see the queue. So by default, in the previous jobs, if you remember, it will be always be default. Now what we're going to do here is we will submit a job. We'll submit a one MapReduce job to identify that this concept is working. We are able to submit a job onto a particular queue. So find dot minus name. So Hadoop jar what count. Let me first say Hadoop fs minus ls. Do we have data? Yes, Shakespeare data is there. So Hadoop fs, Hadoop Shakespeare. Okay, what count? We need to give the program name. What count? Input data Shakespeare and output data, let's say OPP12. I think it should crib saying that you have not provided the queue name. Yeah. To unknown queue default, because we have, remember that we have removed the default, so that is no more there. So we have removed the default, so we need to give the queue. I don't remember the exact property here. Minus d. If you're trying to say something, I'm not able to hear you. Queue dot name equal to, what we will do, we will submit to engineering.qa. So let's say we'll submit this job to engineering.qa. I'm not sure what is that is the property name, MapReduce.q.name. Because that's not the property name. Should be MapRed.q.name. Let me just search the property for that. You don't have to write. That's why you don't have to submit that. That's why you actually install the client machine, install the client configuration. So whenever you do the client configuration, it will automatically on that machine, it will populate the address of the name node, address of the resource man, lot other properties onto that machine. That's why you're able to perform the operation. If or else I will, or else if I don't install the client configurations, then I have to actually provide the address of the name node and the address and the resource manager. Right now, since you have installed the client configuration on all the machines, so you don't have to worry about this. Yes, minus, you can do that. Minus d fs dot default dot name, minus d yarn dot resource manager dot address, minus using the minus d. Forget about mapred dot q dot name. Is this mapred dot job dot q dot name? I'm not sure whether this is the property or mapreduce dot job dot q name. Let us figure it out. I'm not sure. Mapreduce dot q. Okay, this is the property. Mapreduce dot job dot q dot name. Unknown queue engineering.qa. Okay, then it has taken. That gives just QA. Not sure it does should work like this. Yeah, it has now submitted. To now we can go to our Ambari. Refresh this page. You can see that the job which we have submitted, it has been submitted to the QA queue. And see that percentage of the queue, percent of the cluster, everything it has used it. So if you see, it has actually taken whatever we have defined for that particular queue, and it shows in the green. Configured capacity 80%, maximum capacity 80%, used capacity, it's okay. It's actually consuming more than what it is meant to be.
So
Yeah, I'm not able to hear your voice properly. Can you please?
again, is there? Can you hear me now or no? Still the same issue.
No, it's still an issue.
I just know what's wrong.
So actually that completes your capacity scheduler setup. So that's how you are going to submit, that's how you are going to set up the capacity scheduler, and that's how you actually give the job name. That's actually how you submit your MapReduce job onto a given queue. So I'll just update this for my reference as well. No. Even if it is not allowed, you can provide. Right now, I am providing the mapping. So you can actually change the mapping that this user should be able to submit the job only onto this map, only onto this mm, queue. You can provide that. You can provide those settings, stringent settings. Yeah, I think you have not seen that, or you have not following me. No, DB. Where DB?
Hello?
Where is the DB you are talking about? Which DB you are talking?
Okay. Yeah, are you able to hear me?
No, I cannot hear you still now. You go to Yarn QA Manager. I got your question. You go to your Yarn QA Manager, QA. In the QA user, you can see that. Click on the QA. Now, what is the state? Submit application. Which all, who all can submit the application onto this queue? I want to custom user. I want to just say EC2 user can submit the job to this particular queue. Okay, now save this. Custom EC2 user, EC2 user. Okay, now for any other queue, I will remove the blank. I will leave blank. It says that leave blank to deny access for everyone. Now I go to advertisement, I leave blank. I go to sales, I leave blank. I go to services, leave blank. I go to custom, leave blank. Click on the customs. It says that leave blank. Now you cannot use EC2 user other than the QA. Actions, save and refresh queues. EC2 user can submit only to QA queue. And now I'll try deploying onto my, and now once I do the refresh actions, I will try deploying the same job to development QA, development queue. It should deny the action. It should deny me straightforward. Let me give the different output directory name. Very weird, EC2 user. It is development. It is able to do that. EC2 user QA. I think I have done some mistake. Maybe I have. Let me just reconfigure it again. Yarn QA manager. Where this info will be saved. This info is saved with respect to the Ambari. So it will save in somewhere Ambari database and everything. But I am trying to showcase that right now I have given only for this. Oh, not effective user. Leave blank to deny access for everyone. I have given for this. Let me just figure it out. User limit factor, submit application, leave blank to deny access. Anyone? I'm not sure why it is not taking it up here. I'm not sure. Save and refresh queues. Do you have to restart manager, resource manager to get into account? Oh, it's there. No, it's restart. It has automatically restarted. Now let me just check it out whether development it should take it up. If it goes, then I have to figure it out why it is going to development. Yeah, it is going to development actually. Though we have specified here that we don't want anyone to submit the job on development. So let me figure it out that later and I'll let you know. Okay. So that's all for today. And the next class, you next class, if time, we'll talk about the security, not security, rack awareness. ACLs will cover the security, rack awareness, and alerts. That's a small topics, but then the very major topic which is remaining right now, the next big topic is the security, wherein we'll start with LDAP settings, then Kerberos, Knox, Ranger, ACLs. That's it. Okay. So let's meet in the next class. Thank you.